Hello, folks. This is the coding teacher, and this is part two of how to tackle the system design interview question. In this part, I'm going to present the topic outline of the things that you should study, along with resources to get good at learning about these topics. Okay, knowing how to answer the question is only important if you have the knowledge to answer the question correctly, right? So that's what I'm going to be spending time on today. So the following are the things that you just have to understand in order to have any hope in doing well at a system design question. So step zero, actually have built a CRUD API end to end. Okay, so there's no substitute for experience. You have to actually, roll your sleeves up. And if all you've done is little snippets of code that integrate into some massive framework that you don't understand at work, that is terrible. You're gonna have a very hard time passing the software system design interview. That if that's all you've ever done, you need to roll up your sleeves, pick something that you're relatively comfortable with. So like, don't go into something that's brand new that you're gonna barely be able to forge ahead with the implementation. So if you work in Java, pick like Java Spring and do like an end-to-end API um, building. Make sure that shoot for something that includes authorization and authentication, and that has at least two database entities. Okay, maybe like, I don't know, users and blog posts or something like that. Um, then first topic, first actual topic. So step zero is practice. You have to practice, and then hopefully, as you read over all these topics, you come back to your project and fix problems that it had. So that you can see how things are correctly implemented as well, right? So, topic number one, HTTP. Okay, go read the whole HTTP tutorial at tutorialspoint.com and memorize what HTTP requests look like and all the little contracts that are available between well implemented HTTP clients and servers. Okay, a lot of people don't know anything about HTTP. All they know about requests and responses is whatever their backend framework exposes to them as a programming abstraction. So they don't even think of these of HTTP requests as plain text strings that have to follow a specific formatting in order to be deserialized on serialized on one end and deserialized on the other end. Okay, that should not be you. You're gonna have a hard time doing well at a system design question if you think of HTTP requests as programming abstractions, because they are not programming abstractions. They are text strings. It's a text protocol, and you need to understand it. There's a lot of things, a lot of built-in behaviors that clients have. Like if they receive a response, an HTTP response with this particular header, they're gonna do something. They're gonna save that file and hold on to it for a specific amount of time. They might create a cookie. Bunch of stuff that is built into the protocol like that you should know about, so that you can design good systems that make use of it, right? Topic number two, databases. This is, in my opinion, the most important topic, so I'm going to spend a lot of time on it and give you a few resources. First, you should know how databases are queried, of course, right? You should be, and you should get this from step zero. Like if you built a real project, you're going to know how to access the data in your database. You should know how entities are modeled as well. You should know what normalization is, when normalization isn't good, what database indexes are, the drawbacks and trade-offs of having indexes. You should also know the different kinds of databases: SQL versus key value versus document versus column store. Those are the main types that I think are relevant in 2020. Um, there's a Berkeley class called CS 186, which I think is the best resource I've ever seen on database theory foundations. Okay, so word of warning, the first 2 or 3 lectures are insanely abstract and theoretical and will require a lot of effort to understand how they connect to real databases, but they do connect to real databases. It's just not spelled out for you. And then there's like 1 or 2 lectures that are super basic, just describing SQL syntax. And then you start seeing the meat of the class, and it starts coming together. You start seeing how query plans work, and you start building an intuition for how databases work. I actually only did about half of the class, but I repeated this first half of the class 3 times, and taking notes each time and trying to memorize all the content and understand all the content. One of the things I found super valuable in this class is that they really put everything in perspective about how different database technologies are basically all based on the same principles, and they just make different trade-offs. Okay, so it really demystifies all the hype around new database technologies. Another thing you should do, is go back to your CRUD API, the one that you did in step zero, and it should have at least 2 or 3 entities. Generate 20 million records for those 2 or 3 entities. Okay, have a table with 8 or 10 attributes for your users, and a table with a large field for your post, for example, and generate 20 million of 20 million records in each of those. Then load them up into your database, load them up into MongoDB and into Postgres, and compare the performance of querying them. Query them by different fields. Use more complex where clauses. Look at the database size when you have 20 million records and a bunch of indexes. This is important because a lot of people don't have any kind of intuition about what big data is, and they think that you need some sort of hyped up bullshit big data product like Hadoop to handle 10 or 20 gigabytes of data, and you do not. So if you go through this experiment of building your own databases, and you see a 5 gigabyte database can return a query in 3 milliseconds, you start forming an intuition for what big data actually is. Another resource that's super helpful is the book SQL Performance Explained. Again, with this one, you read 3 chapters, and if you actually memorize the contents there, you'll be near the top in terms of database index knowledge among engineers. And it has the added benefit that it goes really deep into the implementation of B trees. So that's another data structure that can come in handy in data structures questions. Topic number 3, DNS. So this one, you shouldn't go too deep on it. Just know a little bit about how the internet works. Okay, you should be able to answer a question about how a request finds its way to the right server and have some sort of notion of the OSI model. You don't have to memorize all the layers, but have some sort of notion of how things get converted from electrical pulses to text to objects in an application, back to text, back to electrical pulses, and they go through packets and frames in between. Have some notion about that. Number 4, security. So when it comes to security, the vast majority of software engineers are insanely, just pitifully weak. So the bar is not high at all. Actually, the bare minimum you should know is that HTTPS encrypts traffic, that HTTPS is necessary for any application where customers send you information, and you should know how authentication authorization work. I think at least just one modern token-based setup for authorization authentication. And I think if you memorize 5 of the top 10 OWASP threats and memorize their attack vectors, and then read the Auth0 blog and memorize how JWT based systems work, you will be in the top 5 to 10% of security knowledge in software engineers. People don't know shit about this. And it's an opportunity to shine, therefore. And then topic number 5, basics of horizontal scaling. Okay, so the final topic in this list is to understand the basics of scaling a web system. This is a hard topic to learn, and it takes a ton of time. I would recommend that you start by just knowing the very basics of scaling. Google around blog posts about scaling, and whenever you don't understand something, Google that topic, and then when you don't understand something in that second level of results, Google that, and so on. And I provide a pretty good entry point in the resources section below from the DigitalOcean blog, which in general is a great resource, and there's tons to learn in there. And once you feel more or less comfortable with the concept of load balancers and stateless RESTful services, go ahead and read the book Designing Data Intensive Applications by O'Reilly Publishing. I think that basically if I had to pick 3 materials, it would be the DigitalOcean blog, this book Designing Data Intensive Applications, and a Cloud Guru, so that it's not all ethereal and all conceptual. Take a class on a Cloud Guru. It's like a 10-hour class on for the Solutions Architect Associate certification. You don't even have to finish it. They're done with the material after 9 hours, and then they give you 9 more hours of additional details. So go ahead and take that class, and it'll really shed light on and connect the concepts to the implementation of things. And I think that's the name of the game. You got to have the concepts, but you also got to have a notion of how the concepts are implemented when it comes to scaling. So there you have it. Just like for data structures and algorithms, when it comes to system design, what you want to do is establish a full foundation first, set a foundation of knowledge regarding the basics of all these 5 topics that I've mentioned, and don't go too deep into any one particular topic. Tackle all 5, set a basic foundation on all 5, and then focus on more diverse studying and more diverse practice. Don't be worried about GraphQL or PubSub event-driven systems if you don't know what a database index is. Okay, basics first, wax on, wax off in this motherfucker, like I said before, and foundational topics first, advanced hipster tech later. So that's it for me today. This is the coding teacher signing off. If that was informative, please hit the like and subscribe button, and I'll see you next time.